This camera, part of a flying laboratory, is recovered by Clyde Holliday of Johns Hopkins, who prepared it for its trip to the upper stratosphere. Rivaling the fantastic imagination of Jules Verne, the camera brought back a record of a flight into the heavens of a captured German V-2 rocket. At White Sands, New Mexico, the huge missile takes off. Air Force pictures show the rocket in flight, and the flying camera automatically takes over. The huge projectile drops the Earth behind at the tremendous speed of 4,000 feet per second. The rotation of the rocket causes the planet to spin before the lens, and the camera photographs the Earth 65 miles straight down. The horizon, 720 miles away, and the curvature of the Earth are astonishingly apparent in this still picture from the film. An observer in the rocket could have seen San Diego, Salt Lake City, Kansas City, and San Antonio. Approximately 1,600,000 square miles of the Earth's surface, designed by Hitler to annihilate Allied nations, now serves the worthy cause of peacetime research.
Averaged 88 miles an hour on a British bike. At White Sands Proving Grounds, New Mexico, a captured German V-2 rocket was recently fitted up as a camera carrier for a scientific experiment. The idea was to see if rockets could be used for photographic reconnaissance and to obtain cosmic ray data and weather information. How this turned out, we're not told, but one thing's clear: you do get a good look at the Earth if you go by rocket.
At the end of the Second World War, technological developments spurred by that conflict accelerated scientific breakthroughs. One of APL's first post-war innovations was to turn a weapon of war into a vehicle for research and exploration. In 1946, research teams at the White Sands Proving Ground began using captured Nazi V-2 rockets to probe the outer reaches of the atmosphere and space. Two members of the lab's high-altitude research team, J. Allen Hynek and Clyde Holliday, realized that a camera mounted to the rocket would be able to take scientifically valuable and remarkable images from high altitude. Holliday modified a 35mm DeVry movie camera to withstand the shock of launch and landing impact. He designed a special magazine to protect the film, driven by a 24-volt electric motor taken from the computer of a B-29 machine gun director system. The entire camera was then placed in a duraluminum box 3/8 of an inch thick, with only the lens protruding. For the curious, the film was Eastman Super XX, exposed at 4 frames per second. The aperture was set at 5.6 and the shutter speed 1/50th of a second. On October 24, 1946, the V-2 carrying Holliday's special camera roared 65 miles into the New Mexico sky. Just a few minutes later, its fuel expended, the rocket fell to Earth, sending the camera feet per second. It took until the next day to recover the camera. The lens and batteries were smashed off, but the armored film magazine inside survived. The grainy black and white images within, the first ever taken of our planet from space, became a global phenomenon. Never before had human beings seen their results of these tests now are pointing to a time when cameras may be mounted on guided missiles for scouting enemy territory in war, mapping inaccessible regions of the Earth in peacetime, and even photographing cloud formations, storm fronts, and overcast areas over an entire continent in a few hours. The following years would bring many more impressive images and film. In 1948, APL produced a pamphlet called So, clips from more than 1,000 publications that covered the Earth picture. Holliday and Hynek showed us how science can be rewarding and inspiring, using what had once been a tool of terror to give us a never-before-seen view of our world.